In our research in statistics, whether we're talking about an experimental design or an observational study, what we want to look at is if I vary one variable, how does that impact a different variable? So we want to start with what's called an explanatory variable. An explanatory variable is what we call a treatment variable. Sometimes in our more algebra-based math class, we might have had a term called independent variable and dependent variable. Well, the input or independent variable is what we're calling right now the explanatory or treatment variable. And then follow that up with our response or outcome variable. So we have our explanatory treatment variable, which would be our input variable. And then the response to that explanatory variable is what we would call our outcome, or that's our output variable. Now, there's an example in the textbook talking about a study from cell phone usage, and they wanted to know whether or not cell phone usage was causing an increase in brain cancer. So holding the cell phone up to your ear, was the radio frequency off of the cell phone causing an increase in brain cancer? So to define these terms based on our definitions here, we would say that our explanatory or treatment variable in that study is going to be the cell phone usage. And then we're looking at whether or not that cell phone usage impacted an outcome of brain cancer. So response variable or the outcome variable to this study would end up being brain cancer. Now let's look at another idea in variables. These would be lurking and confounding variables. So we're going to look at a different study here. In this particular study, researchers wanted to determine whether or not senior citizens, 65 years or older, were benefiting from the flu vaccine. So they looked at 36,000 seniors over a period of 10 years, divided them into two groups. One group of seniors received the flu shot and the other group of seniors did not. After this 10-year period, they determined that 27% of those who did get the flu shot were less likely to be hospitalized, and 48% who did get the flu shot were less likely to die from pneumonia and the flu. So when we look at that study, you might want to ask yourself, okay, well, based on those results, do you think it would be a good recommendation to tell seniors to go ahead and get a flu shot? Well, most of us, in looking at those numbers, would say, yeah, I think it might. I mean, surely it couldn't hurt. If you're 27% less likely to be hospitalized and 48% less likely to die just from getting from pneumonia and the flu by just receiving the flu shot, why would you not? Well, the one thing that we need to consider in these numbers, in these descriptive statistics that are given is there anything else that could be impacting our explanatory variable to get these results? And that's what we're going to call a lurking variable. So a lurking variable is an explanatory variable. It's that input variable that wasn't considered in the study, but does have an impact on the outcome or the response variable. So when we think about these 27 and 48% results, is there anything that could have been not considered ahead of time that would have impacted the outcome and the results of these studies? One of the things we could consider would be the age of the participants. So it says here that we're looking at seniors that were 65 years and older. Well, I would probably argue that the age of a 65-year-old versus, I don't know, maybe an 85 or a 90-year-old senior could be different. We might also consider health status. What was the health status of the 36,000 seniors? Were they all in good health? Were they, did they have any underlying health issues? That's really not discussed here as far as being a factor in the overall health of these seniors who you were following. Another factor could be mobility. Were any of these seniors, or was there a portion of these seniors that were more mobile? Maybe they were around other people more, as opposed to some who were not quite around, not quite as mobile, not around other people. So in other words, age, health status, mobility, all of those things could be considered lurking variables, in that they were variables at the beginning, right? Their input is into the study, but they are not considered, or they were not taken into consideration for the output, so the response. One more variable we're going to discuss quickly is called a confounding variable. And the confounding variable is an explanatory variable that was considered in the study, but you don't really have any idea how it would have impacted the outcome. So on a different note, not the flu shot, but on a different note, if we want to consider a confounding variable, let's take, for example, if I wanted to study online class results, like whether or not students do better in a face-to-face versus an online class. A confounding variable in that situation might be the time of day my face-to-face students were participating. So I know from experience that an 8 a.m. class has a different participation rate than, let's say, an 11 o'clock class. Maybe students are not awake early enough in the morning to be able to participate, and that is impacting the outcome of that study. Or perhaps I have a 1 o'clock class where people are full or they're hungry, one of the two, so they're having a hard time concentrating. And although that is something that I can consider when I create my study, I'm not exactly sure how is that impacting the outcome of my study. So in addition to our explanatory and response variables that we've seen, we're also talking about lurking and confounding variables.